today we will be dealing with properties of matrix operations. Particularly, we are going to discuss Theorem 1.3, which is the properties of scalar multiplication. So these are the theorems. R times SA is equal to RS times A. B, R plus S times A is equal to RA plus SA. C, R times A plus B is equal to RA plus RB. And D, A times RB is equal to R times AB is equal to RA and B. We are asked to verify letter D. For R is equal to -3, A is equal to 1, 3 to -1, B -1, 3, 2, 1, -3, and 4. So we are going to show that when we multiply A times the product of R, which is -3, times our matrix B, it will be equal to R times the product of A and B. And also, it should be equal to the product of R times A times B. Firstly, we have A times the product of R, B. So A, 1, 3, 2, -1 times R is -3. Our B, -1, 3, 2. 1, -3, 4. 1, 3, 2, -1. Multiplying -3 to each entry, we have +3, -9, -6, -3, +9, and -12. This time, we are going to multiply the row to the column. But before we go on, let us check first if it is possible to multiply them. So we have a 2 by 2 matrix times 2 by 3. Possible. Our result would be a 2 by 3 matrix. 1 times 3 is 3, plus 3 times -3 is -9. 1 times -9 is -9, plus 3 times 9 is 27. 1 times -6 is -6, plus 3 times -12 is equal to -36. Next, we have this row multiplied to this column. We will get 2 times 3 is 6, plus 3, -18 minus 9, -12 plus 12. Solving it further, we will get 3 plus -9 is -6, 18, -42, 9, -27, and 0. So remember, we got -6, 18, -42, 9, -27, and 0. Now, let us go to our next equation, and the answer or the result should be the same. Our scalar, -3. Our A, 1, 3, to -1 times -1, 3, 2, 1, -3, 4. -3 row times the column. -1 plus 3, 3 plus -9, 2 plus 12. Two times -1 is -2, plus -1, 6 plus 3, 4 plus -4. So negative 3 times negative 1 plus 3 is 2. Negative 6, 14. Negative 3, 9, and 0. Multiplying negative 3 to each entry, we have negative 6, 18, 42, negative, positive 9, negative 27, and 0. It is the same with our first answer. We're down to our last equation. We have R times A times B. So negative 3 times our A is 1, 3, 2, negative 1 times our B, negative 1, 3, 2, 1, negative 3, 4. This will give negative 3, negative 9, negative 6, positive 3 times negative 1, 3, 2, 1, negative 3, 4. Again, we are going to multiply the row and the column. We will have 3 minus 9, negative 9 plus 27, 6, negative plus negative 36, 6 plus 3, negative 18 plus negative 9, negative 12 plus 12. 3 minus 9 is negative 6, 18, negative 42, 9, negative 27, and 0. Therefore, letter D of theorem 1.3 is proven.